We have here a scatter plot showing the cost of a shuttle ride as the distance to the airport increases. We can see a positive trend, a positive association. As the distance increases, so too does the cost of the shuttle. The next question to ask is, what is the trend line, or the line of best fit for this data? If you look carefully, you see that they are not perfectly in a line, and this makes sense because this is real-world data. This is not a block pattern where it will always be over 1 up the same amount every time. So we have to find a line that fits the data. So grabbing a ruler, we first think about how steep the line is. That's clearly not a good fit because that's not steep enough. That's not a good fit because that's too steep. So we try to eyeball approximately how steep the line should be. Then we think about where to put the line. This is clearly too low, and this is clearly too high. So we make our best estimate of where that line should fall. Now, as you can hear in my language, this is not precise. In a later math class, you'll learn how to do this exactly to find the best fitting line for the data. For now, though, a good fitting line is fine. So our answers will not always agree. My equation, your equation, and your friend's equation may all be slightly different. Once you think you found a good line, go ahead and plot that line. Our next task is to find the equation of this line of best fit that we just drew. To do that, we're going to take note of a couple of things. First, we do not want to pick data points. We want to pick points on the line. We're trying to find the equation of this line, so we need points on this line. Now, my choice for line of best fit was a good one because my y-intercept is easy to identify as 0, 8. So the first thing I will do is I will make note of the fact that my y-intercept is 0, 8. Next, I'm going to need to find another point on that line. I scan that line until I find a point whose coordinates I'm very comfortable with, and I spot right here 10, 18. So we'll mark down the point 10, 18. I now have 2 points that are on the line, one of which is the y-intercept. Now, we have our 2 points on the line, and it's time to find the equation of that line. We know it should be of the form y equals mx plus b, where m represents the slope and b represents the y-intercept. We already have the y-intercept, so all we have to do is figure out the slope. To find the slope, we need to think about how steep the line is. To do that, let's think about a slope triangle. So let's go back and look at our 2 points on the line, 0, 8 and 10, 18. We think about the horizontal movement or change. Well, we started at 0, ending at 10. And we think about the vertical change. We started at 8, and we ended up at 18. From 8 to 18 is up 10. So our slope triangle is change in y divided by change in x. The change in the y was 10. The change in the x is 10, and 10 divided by 10 is 1. So the slope of our line is 1. Substituting 1 in our equation, and knowing that 1 times x is just x, we have the equation for the line of best fit. Now that we have the equation for the line of best fit, it's very useful for doing things like making predictions. looking at this graph, it's not easy to say how much would it cost if we had, say, 60 miles from the airport, because 60 is well off our piece of graph paper. Well, now that we have the equation, it's easy. If the distance was 60 miles, then x is 60, and it's x because that's what's on our horizontal axis. Substituting 60 into our equation for x, we find that y is 68. This tells us that a 60-mile trip to the airport would cost $68.